Good morning, ladies and gentlemen. My name is Yusuf Abdullahi Dadebola. I will be your host for today's chat with experts. Today, the chat with experts, the episode 6 of Chat with Experts, organized by Institute of Data Science and Artificial Intelligence Nigeria, will be focusing on manufacturing and production analytics at a glance. Manufacturing and production analytics at a glance. The speaker for today's event is Mr. Stephen Ikechukwu. Mr. Stephen Ikechukwu has a national diploma in electrical and electronics engineering, and he graduated with Bachelor of Engineering in Computer Engineering. He has more than 8 years post-graduation experience as an IT professional. He is a certified member of Computer Professional Registration Council of Nigeria, CPN, Microsoft certified Azure Data Engineer Associate. Also, Microsoft certified He is a certified member of Computer Professional Registration Council of Nigeria, CPN, Microsoft certified Azure Data Engineer Associate, Microsoft Certified Analyst Associate. He currently pursues his master's degree in computer engineering at Firat University, Turkey. His postgraduation research interests focus on real-time target detection for defects and quality control in hot-rolled steel manufacturing industry. Please permit me to welcome Mr. Stephen Ikechukwu for today's presentation. Over to you, sir.
Yeah, thank you, Mr. Abdulwahid, and thank you to everyone that's on this meeting already. And thank you for IDSAI for this time we need to share ideas and thoughts regarding manufacturing. Without wasting much time, I would have to go straight into the event and start my presentation so we can get this done as fast as possible. I guess in less than 45 minutes I should be done with my presentation. Thank you once again. I'm Stephen Ikechukwu, and you've done justice to the introduction, and I wouldn't have to go back and forth with that again. So you're welcome. Let's get started. Okay. I'll be presenting on manufacturing and production analytics at a glance. Before I go further, I would want to say, one, I'll be using manufacturing, I'll be using production, I'll be using industrial setup interchangeably. So when I use maybe industrial manufacturing or industrial setups, I mean the same as saying manufacturing or production, so that we don't get it a bit confusing. Now, if you're going to be looking at industrial manufacturing and you want to deal with analytics in that space, you would want to ask yourself, why would industries even want to get involved in analytics for what they do? The reasons are obvious, and for years, analytics in the industrial setting have been growing and been growing over the years. And I would want to just make something clear that's a bit more recent. Sometime in 2015, the EU commissioned a project which they titled the Twin Control Project. That project was what gave birth to what the EU actually termed Industry 4.0 and factories of the future within the EU. What was their main idea for this? Their main idea was, one, they saw themselves losing out in the industrial space because, one, a place like China and some other Asian countries were beginning to pull a lot of weight within the industrial manufacturing sector, and it became a thing of concern to the EU, and not just EU, but I'm using EU at this instance to now buttress why that is important. The EU was concerned because, one, China, for instance, began to produce a lot of the same products that the EU countries and their industries shone out over the years at higher costs, at lower margins, and all of that. But China could produce the same products at a reduced rate and then with very big margins. And then over time, they also grew their tech and human capital. And the EU needed to look at a way to deal with that. So they commissioned the Twin Control Project. The Twin Control Project is about marrying and linking the industrial manufacturing physically with a visual environment. So you create a visual system that mirrors identically with the industrial setting in such a way that simulations within the visual setup are the same with what happens in real life on a production floor. In such ways, you'll be able to get information about how machines respond to different conditions, how manufacturing happens, why some defects come up during production, and then how that can be stopped in real time. So that gave birth to factories of the future, which some other people use interchangeably with Industry 4.0 in some other scenarios, but they are almost the same thing, driven by the same idea, economics. Industrial production is geared at economics. Every producing country is more interested in the economics of production, not just because they want to set up factories. They are setting up factories because they want to make money. So they're always looking at ways to make more money. So that gives a background about why that is really important, why it's justified to have analytics set up. And like I didn't mention earlier, one, I wouldn't want to go into defining what analytics is or the basics of analytics, because I'm basing this presentation on some preliminary assumptions, which are, one, that participants here on this platform have an idea what analytics is. So I wouldn't want to focus on that. I would want to now take it straight into what we need to talk about. If you look at industrial analytics, like what I have said earlier, you'll find out some of the justifications, which are competitive and profitable manufacturing processes. These are the reasons why analytics are relevant in the industrial setting. Manufacturing efficiency for minimal resource wastage. You cannot rule out resource wastage in manufacturing or production, no matter how hard you try. You can't be 100% efficient. But what industries keep doing is to make sure that over time, the wastage they churn out, the kind of raw materials they scrap as they produce, is reduced over time. And how do they achieve this? Analytics play a significant role in that, apart from other factors. There's also the need for innovation at scale and optimization. industries are not static, they are dynamic. If you take any specific industry and look at it in the last 10 years, you will notice that there's been growth in the kind of tech they employ and deploy in their processes. So industries want to be able to innovate without disrupting their present production, without disrupting their present system. So how do you do that? So you should be able to innovate at scale, meaning that you should have a modularized innovation that keeps growing without having to affect what you have on ground already. So as you keep going, you're increasing your tech capacity, you're increasing your creativity and innovation without having to lose on what you already have. And then you optimize your cost, because no matter what you do, cost optimization is very, very important. So you must optimize your cost. As you're innovating, your innovations should be less costly over time. Though the initial capital investment could be higher, because that's true with tech. Initial investments are always higher, but the cost of maintenance, the cost of running this tech over time will begin to rub off on the initial overlay you had to part with to deploy the technology. So that's innovation at scale. And then you have to also look at adaptive manufacturing. Why is adaptive manufacturing important? Manufacturing, like I said, is not static, it's dynamic. So it should be adaptive. Whatever technology you're deploying, whatever innovation you're coming up with should be in such a way that it's flexible, is adaptive. You can tweak it. You can adjust it to meet trending issues, to meet with changes in your operating environment. You don't need to maybe completely scrap a production system because something has changed. It becomes a problem because it will impact your bottom line. It will impact your capacity to actually make money, to sustain your production and keep your personnel as they should be. So your systems should be adaptive. These are some of the reasons why analytics in the industrial setting is very relevant. And again, you look at high quality products, which is a very big factor in industrial production. In the industry, physical products are important. It's not like the services sector where what you offer is just services. In production and manufacturing, you're offering physical products, tangible products that people can touch, they can feel, they can see with their eyes and all of that. They can interact with these products in a physical manner. So you need to be able to give your customers products that they can trust, products that they can use and feel satisfied that this is actually worth it. Because if you're not bringing out products that people are satisfied with, no matter how beautiful the product is, over time they will begin to go to your competitors. You begin to lose your customers over time. So high quality products is very important, and that is where analytics still comes into play. It does that. So with this, I've given an idea of why industrial analytics is such an important thing to play around with in the industry, and what every industrial player should pay attention to, no matter the industry or sector you operate in. Is across board, is the same everywhere, no matter your industry. Then I will just have to lay a little insight into analytics. You can say analytics is a field of computer science that uses data and math to answer business questions, discover relationships, predict unknown outcomes, and automate decisions. That is very true. That is basically what analytics is about. Working with data, deploying math concepts, statistics to answer basic business questions, to deal with relationships between different factors in the industrial setup, for instance. It is a diverse field and is used to find meaningful patterns in data and uncover new knowledge based on applied mathematics, statistics, predictive modeling, and machine learning techniques. Is diverse analytics. So that's why we are looking at the industrial aspect of analytics, because analytics is diverse. In industrial analytics, you can just describe IA, industrial analytics, basically as collection, analysis, and usage of data generated in industrial operations. Take, for instance, if you're dealing with a steel industry, if a machine is producing, is running, you have to be getting data concerning the IC setups, the machine cutting mechanism, the alignment mechanisms. You need to look at the angles and all of that. So this data is being fed from the machine, and you should have a way to acquire it in real time and analyze it so that you can make sense of it. So industrial operations and throughout the entire product life cycle, very important. Throughout the product life cycle, it's not something you jump in at the middle and then you disappear at some point. It's end to end. Industrial analytics is end to end, from beginning to the very end. You have to pick out data that you know is useful for your operations, applicable to any company. That's true. I've said that is manufacturing and selling physical products, right? It involves traditional methods of data capture and statistical modeling, which is true. The traditional way of acquiring data, statistical modeling, and all of that. You can say this, the traditional way is a bit behind schedule right now, but every new technology in data acquisition is still based on the traditional way, but in an automated fashion with some disruptions here and there, but it's still the same basics. Behind the scene is the same thing that's happening, but either they've become availability of faster processors, better cameras that can operate in diverse kind of conditions, in hazy weathers, in frozen conditions, and all of that. But it's still the same way they operate. Now, we will look at the industrial analytics pipeline. In every industrial analytics deployment, it mirrors a specific kind of pipeline: the physical model, the network, and the analytics base. You can talk about the analytics endpoint, which is the finishing, the end of the pipeline, without looking at what happens in the beginning. Because one, for you to actually do analytics, you would want to be involved in the physical setups and the networking that has to power your analytics platforms, especially in the industry. Because in the industry, what happens is industrial players are not really that interested in having diverse professionals doing some of these things. So they want to have enterprise level applications or products. They can take care of this from beginning to the end. They can have access to their machines and pick out data, put it on the network. If it's not physically accessible, if it's on the cloud, if it's on anywhere, they want to be able to have this data, and you consume it at the end, which is analytics. So it's always good to understand how the other components work in the pipeline. In the physical setup, you can have a fleet of heterogeneity. It could be physically in the same location, it could be in different locations, but tied together in a network, which you call a fleet. A fleet is mostly about a setup of machines in such a way that all of them work together, even though they are not physically close to each other. But what they do impute and impart what the next machine does. So you could have machines set up in different locations physically, but they are cooperating in their operations, and at the end of the day, the final product could be coming out from a machine that's not even physically accessible to the operator at that point in time. So you have a way to manage fleets of machines. There are applications for managing machine fleets in the industrial setup and all of that. And then you look at the network. The network could be what you have physically in one location, But now that doesn't really play out well, depending on the industry anyway. If it's an industry that has different locations and all of that, the cloud has become a central point for them to harness all of their data and interconnect them and bring them on the same platform so that it can be accessible from one endpoint without having to go here and there to pick what you want. So the network component of the pipeline is there. Then you now look at the analytics, which is what data scientists, data engineers, and data analysts are always interested in. Even business analyst is the analytics component that actually catches their fancy, where you have fleet management systems for service providers, for expertise, diagnostics, optimization, and visualization. And you can also have third-party applications like ERP, MES, and all of that, depending on the industry. Most industries actually like to have proprietary products that they use for their in-house needs. That way, they are insulated from what is happening in the outside world, because they don't want a situation where a loophole in a system maybe somewhere else could impact them because they are using a product that every other person is using. So a lot of the time, even when they want to deploy an enterprise application that other clients could be using, they want it to be deployed in a customized manner to suit their specific needs. That way, they are guaranteed some level of security, some level of efficiency in their operations. So if there's a problem at the end of the product developers, it won't affect what they are doing, because the whole system has been decoupled in such a way that they operate independent of each other. Though if they want to push maybe updates or something, it's always a matter of creating a pipeline, a network pipeline from the product designer to the end users of these enterprise applications within a time frame, maybe within a space of 6 hours, 12 hours, depending on the kind of update or maintenance that the system has to undergo. So within that time frame, everybody is on the pipeline, everybody is on the system to guarantee that nothing goes wrong. Once that operation is closed out, everyone disconnects. Even the product makers cannot have access to the end users' systems without authorization because it's decoupled. So the physical layer, the network layer, then the analytics layer, which is the last part of the whole setup. These all come together to offer industries what they need to get the kind of insights they need to optimize their operations and to save costs and become, while still remaining competitive, because you need to be competitive no matter how well your product serves the people. There are always going to be new entrants into your domain that will want to disrupt the market for you. So you need to remain ahead of the game. You need to be on top of your game. You need to be ahead of the competition. So you need to also remain competitive as you go. Context is king, which is very true. Like I said earlier, analytics in the industry is so diverse, and that's true also for analytics outside of the industrial setup. Is diverse in such a way that you need to contextualize what you're doing. So within industrial analytics, context is king. Industrial manufacturing generates huge amounts of operational data at high speeds. That's true, because you're talking about milliseconds, nanoseconds. Product machines, for instance, as rolling hot steel, operate in speeds as high as 1 nanosecond. So you need to be able to grab this information or whatever data you need at that speed also. And whatever analytics product you also deploying need to be able to operate within that time frame so that there won't be any kind of lag. But it is very difficult to extract enterprise level insights from it. That's true. That's true. In manufacturing data, context is king. Without deep understanding of the underlying manufacturing processes and circumstances associated with your OT data, it's nearly impossible to derive meaningful insights that can be integrated back into the manufacturing process for improved performance. Let's pay attention to integrating back into the manufacturing process. Like I said earlier, part of the justifications for industrial analytics is optimized production. If you're just getting using data in the industrial setup for insight that's not actionable, it becomes a problem. It's almost useless. So you need to be able to make decisions in real time with what you're seeing in your data. So there must be a feedback mechanism in such a way that whatever outcome you get from your data, it has to be fed back into the manufacturing process to adjust what's happening. To adjust, for instance, if there's a defect, for instance, if it's a manufacturing line that you're looking at the products coming in and going out through the line, if there's a defect in one product in the production line, you should be able to make a decision at that point and have a way to either isolate that product or to alter the other products that will come after it, so that whatever caused that defect will be corrected in the next production cycle. So the next 10 or so products behind would not face that same situation that led to the defects. So if you don't have a way for doing that, your analytics becomes almost useless because it's not offering any value. It's not offering any value. Real time and speed are very important, and then accuracy are the two main factors you consider in industrial setups for analytics, for quality control, for any other thing you want to do. Speed and accuracy are very important. Anything you need to do have to be happening in real time at higher accuracies. If you're maybe operating in the maybe water bottling sector, your need for accuracy and real-time decision making will be way higher or way lower, than someone operating maybe, for instance, in aeronautics parts production, because you know that in aeronautics production systems, products, raw materials are very costly. So any defect that gets to be scrapped is a huge loss in revenue, and it hits the bottom line of the company. So you need to be able to have a system that's highly accurate and highly fast, very, very fast in response. So in such a way that decisions can be made in split seconds and alter the process without having to repeat the same errors, the same mistakes that led to what the anomaly is you are noticing. So that's that. There must be context. And if you look at it in the other way, you could say they have to be domain expertise, because industries operate in different domains. So you need to contextualize what you're doing within the confines of the industry you're operating in. Someone that is maybe versatile in oil and gas production systems, his experiences, his skills will be quite different, though the basics are the same. But because the kind of conditions he has to operate within, the kind of machines, the kind of equipment he has to deal with are going to be different from someone who is working maybe in aeronautics, for instance. They are using the same principles, they are using the same logic, but because the circumstances are different, the context is different, way different. So they will be needing some contextualized insight into what they are doing. You must understand the context, the domain. You must understand it very, very well. If you're dealing with glass production, you must understand the whole setup from end to end, how these things work for you to be able to make decisions, because you're feeding information or data to computers. A lot of the time, computers are not 100% accurate in what they do. So if you don't even know what you're expecting from analytics, from your analytics outcome, the computer can even mislead you and you wouldn't know it. You wouldn't be able to recognize that something is wrong with the outcome you're seeing. So that's where context comes into play. Furthermore, industrial analytics applications often require actionable insights, like I've said, in real time, A predictive model for engine oil is only valuable if its prediction comes early enough to avoid the failure. That's another thing. Apart from maybe you're just trying to detect problems, you're trying to monitor what's going on in your production systems, you should also have a way, maybe if that's the kind of analytics you're doing, you want to be able to predict problems before they happen. You need to envisage them, and you need to also be able to make decisions to correct them. That way you will reduce failure time, you will reduce downtime, you will reduce the number of defective products, because if a machine is supposed to be maintained at a particular time, and then you notice before that time that some of the operating conditions has changed suddenly, you should be able to proactively take a step to avoid a failure, because you know the cost of failure when it does happen, and then it's still not yet time for scheduled maintenance. So these are part of the things that analytics does in the industrial settings, because you have scheduled maintenance operations, but over time, from experience, you see that before scheduled maintenance happens, a lot of the time machines go down because they are mechanical products. They can go down without notice. So you should be able to monitor these machines and see what is happening with them and make decisions in real time to avoid failures. If it's something that might need to be short, you push processes that's running on a particular machine to the next one, so that the other one can be isolated from the whole setup for maintenance at that point in time. So this is still where real time and accuracy becomes so important. This requires managing a high volume of information generated at the edge and delivering insights to the right person or system with low latency. That's true. Industrial IoT mostly has made it easier to pick out data from remote locations and feed them to maybe localizations where these operations are happening. For instance, in the oil industry, if a production system is offshore, you are not always going to be physically having access to these systems. So there must be edge devices that are actually feeding data, acquiring data, and sending back control information back in real time. This feed it from it needs to be used or to the individuals that actually need them, depending on your specific setup. In maybe in some machines now, what most industry players do is, if you have physical machines that become machines in such a way that in real time they are keeping tab on all the operating conditions of these machines, products, the power inputs, how the machine is dealing with power, how the voltages are behaving, how the frequencies are going, the torque, everything, the pressure on the products, and all of that in real time. They are picking this information, and some have inbuilt processing power in such a way that they can make a little sense of the data, discard what is not relevant, so that they don't end up pushing out heavy data that's almost junk. Maybe it has 10 columns of data, 10 rows of data, but out of the 10 rows, only 2 is relevant for whatever analytics operation that's required on that system. So there are CNC systems that can actually do in-house decision making in such a way that they know, this might not be useful, discarded, so that you don't end up sending 1 gig of them. What you might just need based on your specific needs 100 MB, and some don't have that capacity. They send whatever they get, so it becomes a problem on your network part, because one, you're now having to deal with high bandwidth, high volume of data, and then the latency begins. So these are the different kinds of scenarios that industrial analytics has to be looked in industry control. There's maintenance, there's quality control and assurance. These are different domains. Quality control products and the kind of data we'll have to see trying to solve. So you can actually categorize these needs into three: process control, maintenance, and quality control. Has to deal with situations like you have machinery, you have systems, you have processes that are operating. What do you want to be able to ensure that there's conservative usage of raw materials and energy within process control? Because one, in processes, you're deploying raw materials, you're deploying so much energy into your systems, into your operations. So you need to be able to control how these materials are used, how energy is used. And in this time of green energy, you also having to be looking at, okay, what's the impact of my energy consumption on the ecosystem? How does my energy usage impact my bottom line, my capacity to actually make profit and stay competitive? Because if you don't look at all of these and you don't analyze them, it becomes a problem. You're wasting materials, you're wasting energy that you can deploy into some other usages. It becomes a problem for you. So within your machines, within your systems, within your processes, you should have to be able to harness data that would give you insight into how you use raw materials, into how you use energy. That's on the process control aspect. If you go to maintenance, you're still dealing with machines, you're still dealing with equipment, and in some other scenarios, you're dealing with processes also. But that is always, mostly not always the case. But you can have processes that impact machines, which will have effect on their maintenance schedules, on their maintenance needs over time. So you're looking at how can I increase uptime in order to meet business objectives. Because if your machines are always breaking down rather, you're going to have a problem to meet your business needs. You have a set goal as an industry. You have an idea of what you want to achieve. But if you get yourself into a situation where your machines are always down, your machines are always knocked, then it will impact the quality of products you're going to be pushing out. It's going to impact the number of products you're going to be pushing out, because you might not meet the demands of your clients and your customers. Then that becomes a problem. They begin to look elsewhere. If someone is always having to wait more than necessary to get products from you, the person will begin to look at other options so that they can keep their own businesses going without having to be held ransom by you. That's on the maintenance aspect. Then in quality control, you look at the fact that you're also still dealing with systems, you're still dealing with processes, you're also dealing with machineries, and you want to be able to say, oh, defects and meet their needs. A product could be free from defects, but is not meeting the need of the customer. That's quality assurance, that's quality control. Why wouldn't it meet the needs of your customers? In engineering, there's what is mostly called functionality when it comes to products. For instance, a civil engineer's idea of functionality is different from an electrical engineer's idea of functionality, because suppose they operate with. A civil engineer could say, oh, the door is supposed to swing to the left and is going to be pushing inwards. That's his idea. Because as long as it's concerned functionally, that is right. Because the door shouldn't be in your way as you're going into an enclosure. But an electrical engineer is looking at it from another functional perspective, which wouldn't be wrong. And they have to marry all of these issues together and reach a compromise. He's saying, okay, you're going to be pushing this door to the left, but I have an electrical panel which is on that left side of this enclosure. If you push the door to the left, it's going to impact the capacity of the user to actually have unrestrained access to that panel. The door is serving its purpose. You can go into the enclosure and all of that. You can lock it. You can go out and come in. But there's a problem. The user is not getting his needs solved. He can go in, but he can't have access to the panel that he needs access to at that point in time. So, though the product is good, it meets standard and all of that. There's no defect. There's no problem, but it's not functionally meeting his needs at that point in time. I have a smartphone. This smartphone I can make calls and all of that, but a lot of the time I find out that I cannot use the smartphone with just one hand. I can use it with one hand, not defective, but functionally it's my need over time, because I could be in situations where my two hands are not free and I need to use one hand to do something else while still being able to use my phone. That is why most people don't like large phones, because of the kind of scenarios they operate in. The product is not defective, but it doesn't meet his need at that point in time. So as a product maker, you should always have that in mind. After you have dealt with quality, you've dealt with defects and all of that, your products are not defective, but you should also look at, are they satisfying the customer's needs? That's that for quality control and assurance. So these are different scenarios of use for data analytics in the industrial setup. There are many products out there, and a lot of them are always built to deal with either of these scenarios or all of the scenarios if it is a very robust system. So it's dealing with process control, maintenance, and quality control. And even if it's dealing with all of these scenarios, you still have it in such a way that different kinds of professionals are manning these different units, because the ideas, the logic, the principles, the thinking for these different scenarios are always different. And it's very draining for one person to keep shuttling his mind, his brain, between all of these scenarios at the same time. And he can do that, but over time he begins to break down. He becomes lost in the whole process. So different people, they are analysts and product makers who their ideas are focused on quality control. Some are focused on maintenance, some are focused on process control. So excuse me. So it's always tied in such a way that everyone deals with that. And then let's quickly go to a specific use case. There's an enterprise product called Factory Talk. Factory Talk is made by Rockwell Automation. Rockwell Automation is a big player. Aside from other players within industrial analytics, you have companies like Keyence. Keyence is a bit more into AI. They are more into AI, robotics, vision systems, and they have vision systems that are end-to-end, that have processing power. You have industrial, for instance, product defect systems that they are so robust that they can pick defects, they can make decisions, they can perform an analysis, and a user that's a professional can also build models, specific models, and deploy on their system. So Keyence is that robust, but chaos is a bit more technical compared to what Rockwell does. Rockwell delivers more of a software-based product, more of a soft product, whereas Chaos, IDS, and some other players, they build hardware and software that work together. That's that. So let's look at Factory Talk Analytics a little. Factory Talk Innovation Suite, which is the main product they sell. Innovation Suite is an enterprise analytics solution by Rockwell Automation and powered by PTC. What it does is provides industrial manufacturing practitioners with a complete spectrum of descriptive to prescriptive analytics. Descriptive and prescriptive analytics solutions for achieving business outcomes such as overall equipment effectiveness, overall effectiveness, use energy efficiently, churn out less defective products, and be more optimal in speed and in accuracy in whatever it's doing. If, for instance, a machine is going to supposed to churn out a product that has a dimension of maybe 5 centimeters in width, 5 centimeters in or less, no more. Because if it is higher, if it is maybe 5.1 centimeters, the end user could still use it. But when you are now having to use that product as a part of another product, it becomes a problem, because the other product you will need to couple it with might not have provision for 5.1 centimeters, because in the design is designed to take in 5 centimeters. So what the other guys are going to be producing should be exact. So overall, the equipment should be effective. Improvement, downtime reduction, yes, and quality or process improvement. You need to look at quality, you need to improve the processes. And to understand what Factory Talk actually does, you need to understand traditional approach to analytics. If you look at the traditional app, you find out that, one, you have data from disparate sources, you have streaming data, you have mechanical data, you have applications, and you have master data, which you are using to control the data that's coming from all these other guys. And then you have data integration engineers or an engineering process at one end, which is interfacing between the data and then data warehouse, because you need to land your data somewhere platform you want to push them to. Because why is always that way is you want to reduce the capacity of the burden that the analytics platform has to bear to deal with your data in high speed. You should be able to run it in real time. So if you're feeding it junk data that's not completely relevant, it becomes a problem. It will slow it down. The latency will be impacted. So you need to also have it in such a way that whatever data is that's ending up on your analytics platform has been processed in such a way that errors have been eliminated, invalid entries have been eliminated, business logic, you have been able to apply some mathematical formulas, some process formulas to the data, so that you just extract the one that's useful and then push it to your platform for analytics purposes. So this is basically how the traditional approach to analytics works. So you have the data warehouse, you have the data architect that's in charge of curating setup and the pipeline for your data ingestion, and then your analytics. Then what Factory Talk offers. Factory Talks in such a way that it can handle any kind of data. There's structured data, there's unstructured data, you have disparate data sources. Your data can come from anywhere, any kind of storage system, whether it's in the cloud, whether it's on-premise, whether it's SQL, no SQL, whether they are flat files, tabular files, columnar files, any kind of data structure. Factory Talk has been so primed in such a way that it deals with all this kind of data. You have storyboards that you can find story form depending on the ones you have elements. You actually can tweak, you can deploy custom made storyboards on Factory Talk and all of that depending on what you need. And real-time analytics and task pipelines. If you always, pipelines are always very important in analytics and in data management, because one, a lot of the time you have routine processes you deal with, so you don't want to keep doing the same thing over and over manually. So if for instance you're always deploying or maybe delivering weekly reports or analytics on specific segments of your production system, maybe you have a production line that its turnaround time from end to end is 1 week, and you have weekly analytics set up for that. So you should be able to automate it in such a way that it fires up automatically as a task. So you create tasks with different triggers along the line to fire these processes so that they can happen even while you're sleeping. Let's take, for instance, you have analytics products that's dealing with maybe maintenance, and in the middle of the night you're at home, operators are weak and sleeping, and the system has, from the data is receiving from the production machines, it has noticed that this machine is going to be breaking down anytime soon, even before workers turn up for the following day. So there should be a way that even while you're not there, the system is operating, is functioning, and then it can trigger decisions, it can trigger actions in such a way that problems can be curtailed before they actually go out of hand. So you have pipelines in Factory Talk and all of that. So a routine task, you just make it automatic, that you don't need to do anything again. You don't need to keep reinventing the wheel and all of that. So Factory Talk has a disparate data capacity. It can deal with event ingestion. You can have streaming events, PySpark streaming events. You can have Hadoop events all happening at the same, depending on the kind of setups you have. If you have maybe edge devices that are picking up data on the edge and all of that, so you should have a streaming pipeline that actually aggregates the data depending on how they are coming in and processed at the same time before pushing it to the analytics platform. So Factory Talk takes care of all of this at the same time, because one, it can recognize devices, it can recognize locations for devices, it can recognize configurations on devices. So whatever data that's coming in, it knows where it's coming from. Factory Talk knows where it's coming from. It knows the conditions under which that particular equipment is operating. So with that, it will be able to make sense of the data is receiving from that equipment based on its configuration, based on its operating conditions that Factory Talk is already aware of. And the good thing is plug and play in such a way, not that it is plug and play in the real sense, but it's plug and play in such a way that it has some of these tasks and triggers automatic. You don't need to tell it to do some of these things. It detects a device, it reads the in-memory configuration files on the system, it reads the operating conditions within this equipment, and then it saves it without having to query that equipment again every now and then. If there's a change, it has a routine way of checking whether what it knows about this device, is this still the situation? Has the device name adjust itself and change what it knows to tally with what is happening in real time? So this is what Factory Talk does. It can take disparate data, it can orchestrate streaming analytics, event processing and enrichment, data hosting and staging, which is still an aspect of what the traditional method does. But Factory Talk automates this process in such a way that you have less things to do. You have less. There's an aspect of Factory Talk that makes a lot of sense, that you can actually build an end-to-end analytics product on Factory Talk just by picking and dropping components. If you know maybe a little bit of object-oriented problem solving, not programming, object-oriented problem solving, Factory Talk makes it easy for you to do that. So it provides you tools that you can actually pick components, different components of what you want, data ingestion, orchestration, housing, staging, and all of that, and build an end-to-end pipeline for solving a specific problem. And then analytics. It provides you predictive analytics, operational analytics, real-time analytics, search analytics, graph analytics, and then applications. Excuse me. So these are the things that does on its own. Product analytics. It was a pilot product analytics that I've had to work with Factory Talk. Why mostly? What I want to highlight is in the industry, mostly what industrial setups use for analytics need a chaos product. Chaos is not even going to tell you how much you're going to pay them, how much a product costs. They want to understand what you want to use that product for, the space within which you operate, what kind of processes you engage in, so that they will be able to prime a specific product for your own needs and then give you a detailed proposal. Because one, even if you're operating maybe in the glass production, two different companies are operating in glass production system environment, their processes might be a bit different based on how their systems are designed. So if they are going to deploy the same product, maybe Factory Talk or Chaos products and all of that, it has to be tallied to their specific usage. So you end up not being able to have these things in the public domain all of the time, because one, you can't pay for it. You can say, oh, I want to buy a Factory Talk and see how it works. It becomes difficult for people on the outside to actually know these products, interact with these products. The easiest way people get to use most of them is if they work in industries where they are deployed, if they work maybe in research-based setups where these enterprise systems are being used. Like I've used Factory Talk in a research-based setup that we are trying to look at electrical conductors on chips. Wanted to look at the defects on data buses on chips, so that you can be able to see when there's a break in any of the chip lines, and then be able to determine, okay, what's the width of this break? Due to this break, is there still a communication? Can data still flow from point A to point B with this? Because if it's just a scratch on the surface, there will still be connectivity. But if it's an internal breach, there will be a problem with data going through. So those are the kind of scenarios you might get to either use some of these products over time. But the ideas are the same. If you're an analytics person and you want to do something in the industrial sector, it's a matter of understanding the domain you're playing in, understand what the scenarios are, what do they want, is it process control, is it maintenance, is it quality control. You understand, okay, how are their systems set up, what kind of data are their systems churning out, are their systems even churning out data, because a lot of industrial setups, especially in our part of the world, are not primed in such a way that they fire data from their operations. They don't produce any data, they just keep going. So someone has to physically monitor them to know what's going on, unless in high precision scenarios like oil and gas, refineries, and all of those kind of systems, and pharmaceuticals where you have advanced production systems, because any problem in a pharmaceutical line can be detrimental health-wise for the entire populace. So these are things you actually have to look at. And then in concluding, if you look at what we have said before about benefits of industrial analytics, there was a study that looked at different industries and the impact of analytics on their whole operations, not just in their products, but on the company as a whole. What impact does analytics have on them? What actually came out more properly and more loudly was the increase in revenue. Customer satisfaction were the biggest benefits of industrial analytics, and that is very easily discernible. You can actually imagine that, because if you have an efficient production system that's optimal, you have less defects, definitely your revenue is going to be higher, because you make more products, you have less scrapped products and all of that, so you make more money. And when you have better products, you're going to satisfy your customers better. So if you look at the chart here, you see increased revenue is actually the highest benefit, 33.1%. Increased customer satisfaction, 22.1%. Then you have increased product quality, which impacts the other ones. You have better resource planning, yes, because you have better understanding of how your resources are being used by your production system and your processes, so you'll be able to plan your resources better. If your machine, your process are always churning out scrap, it becomes a problem for you to plan, because you can't say, oh, that this machine is going to turn out bad products at so point in time. It can just happen. But if you have more efficient systems based on what your analytics have told you over time, you'll be able to envisage and plan your resources better. You have better insights on customers' needs. That's true. You understand how your customers are actually interacting with your products. Optimized supply chain. Yeah. You have better demand forecasting. True. Because if you understand how your production works and you can guarantee you will be online, your systems will be online without having to shut down for 1 month, for instance, you'll be able to forecast demand. You'll be able to forecast, okay, look at what our customers are always demanding over time. So that means by next month the demand will be so in so way. Then you plan your own internal processes to meet that same demand. You have lower cost base, cost cutting, true. Better compliance with regulations, that's true. And then others. It is estimated that connected machines and data analytics could eliminate up to $150 billion in waste across industries. That's true. If you check how much industries lose due to defective products, scrapped products, and damaged products and all of that, then you now have to understand what value lies them in terms of optimized products, in terms of innovative products, and they have more money at their disposals, and they save more money that could have gone into wasted wasted operations. And maybe you notice that a particular process technique leads to defective products. You have to adapt your processes to avoid that line of process manipulation and reconfigure it to deal with that, and then you have less issues to deal with. So that's a preliminary insight into data analytics in the industrial sector. If you want to have a deeper dive into analytics in the industrial sector, then you will now have to focus on specific scenarios of use and specific domains. For instance, you want to focus on quality control and assurance. Then you will now have to dive in and see some of the ways to actually ensure better quality products, the kind of technology that's being deployed in that domain. If it is process control, you now have to look at them deeper and understand how you can actually make use of that. So basically, this presentation is just giving an idea of what is at play, and then it should agitate anybody's mind to want to know, okay, if these are the issues that analytics can offer in the industrial setup in my own scenario of use. For instance, if I'm maybe a baker, for instance, I bake breads and I have equipment. Are there ways that analytics can be deployed in this kind of sector, and what could be the scenario of use? Will it be that I'm trying to make sure that I have less bread, I don't waste raw materials in the process that I'm making bread, so that if I bought maybe a bag of flour, and a bag of flour is supposed to give me 100 loaves of bread, I'm trying to see, okay, at worst case scenario, I'm having 98 loaves of bread, so I've lost 2 loaves to wastage. Is there a way to improve that by analytics, deploy analytics products and all of that? So that's the essence of this conversation. You begin to think, how can analytics actually benefit me in what I do, depending on what you do? So that's the import of this presentation, and I'll be bringing it based on what the facilitator guarantees, and let's see whatness and whereness will go from here. Thank you.
A big thank you to Mr. Stephen. Thank you very much for the beautiful presentation. Can you hear me?
Yeah, I can hear you.
Okay. So thank you very much for the beautiful presentation. We really enjoyed the speech that you delivered. So as we all know that the Institute of Data Science and Artificial Intelligence, our goal at the Institute is to focus more on promoting the awareness, people's opinion and understanding about artificial intelligence and data science. We are trying to create a multidisciplinary platform to make people to be aware of the benefits they can derive from data science and AI systems. So please feel free to contact us for any collaboration. And if you think that there are areas that we need to touch that we are leaving behind, especially in the Nigerian context, because our primary focus is more on the Nigerian context. So if you think that there are other things that we need to add up, some areas that we need to focus that are very crucial, to the Nigerian economy or globally, please feel free to contact us, or you have any case study that you want us to assist you with collaboration, supply you with some expertise regarding to artificial intelligence and data science. As you all know that uh, data science and artificial intelligence is applicable in every industry. So far data exists, then you must have something to do with this data to solve critical problems. So thank you very much. We really appreciate your coming. Thank you again to Mr. Stephen Ikechukwu on the beautiful presentation. So now we will welcome questions from our participants. So please, if you have a question, you can unmute and just ask your question directly. Hello.
Good morning. And I'm Mr. Nuruddin. Well done for the beautiful presentation. It's really stuck into the topic. And my question is, I'm a bit diverted. So it's also in line with the quality of products that industries produce these days. You see, there are some regulatory bodies that each industry subscribe to, that's compulsory, and they tend to be those that they must meet up minimum requirements for their products to be able to sell in the public and market. So my question is, after all the rigorous process that all these companies go through in terms of making their products able to meet up with the market demand, what do you have to say concerning other regulatory bodies, those especially set up by government agencies? I want to please throw a little light on them in terms of your presentation. I hope you understand my question.
Yeah. Yes, I do. Yeah, if you looked at
Okay,
okay, yeah, thanks for your question anyway. It's very important too, because one, regulatory compliance is something you take seriously in the industry. So when you're doing anything within manufacturing or production, there are specific regulatory policies you have to deal with. And as a sane industrial player, your processes, your operations must always be aligned based on the compliance demands that your environment regulatory bottleneck to deal with. No matter wherever your company is operating or your production is happening, you need to first and foremost make sure that you understand the regulatory policies you have to deal with, and then tailor your processes to mirror that. Even analytics, if you looked at the last second to the last slide, you'll find out that compliance with regulations, regulatory compliance, is one of the benefits of analytics, because one, you understand what the regulatory policy is, you know what they are expecting. So in your entire end-to-end operations, you are pulling out the kind of data that will help you to look at how your processes is complying with these regulations, and then to see if there are areas of improvements, and if there are areas that are making it difficult to comply and meet those demands, then you adjust and tweak to ensure you actually meet what you're supposed to meet with regulation. You cannot operate outside of regulation anywhere. So AI, data science, analytics, or whatever must be tailored to mirror regulatory compliance anywhere you operate in. I will give you an instance. A company like Amazon Web Services. Amazon Web Services operates globally, but they deal with different kind of regulations in different spaces. That they now have a way of providing specific and tailored services to specific regions. The kind of operations AWS deploys in China and parts of Asia is completely different from what is obtainable in Europe. Even within Europe, I'll give you an instance with Azure. Azure has a specific, a tailor-made service for Germany. Even in Europe, why do they have to do that? Because that's not obtainable in France, even though the two countries are in Europe. So they still have to mirror their processes to meet those regulations. You cannot say, oh, because I'm a global company and we are too big and all of that, our processes are streamlined to be based on what the environment demands. That is that. So you cannot rule that out. As a practitioner, for instance, if you're a data scientist, if you're an analyst, if you're an AI engineer or a data engineer and all of that, based on your industry and based on where you operate in, you should have an idea of what the regulations are. Data handling policies, product compliance, and all of that. With the processes you are deploying, will it end up giving you the kind of product that will comply with these policies? And if not, how can you mitigate that? So you deploy the kind of analytics process that will also keep monitoring that compliance from the production compliance. It drives everything you do aside your internal business policy and all of and objectives and all of that. They have to stay under. Thank you.
Okay. Thank you for the answer, Mr. Stephen.
Okay, thank you for the response. I understand very well.
Okay, you're welcome. So,
thank you.
Do we have any other
appreciate
question from the participants? Any other question? Okay. In the absence of no question, we are going to call this episode, we are going to bring it to an end. The video is recorded and it will be made available to our emails and our online platforms. So as we said earlier, please feel free to contact us on any area you think we may be of benefit to you when it comes to data science and artificial intelligence advocacy, system or design, conceptualization, and also deployment. Thank you very much. We hope to meet you next month for the 7th episode of Chat with Experts. Thank you very much and have a nice day.
Thank you. Have a nice day.
Okay. Yeah.